Good morning, children. Today we are continuing with the chapter set 2 polynomials, and today's topic is factor theorem and its applications. And the previous topic we dealt was remainder theorem. There is a lot of relationship between remainder theorem and factor theorem. Factor theorem is one of the part of the remainder theorem only. Remainder theorem says that when a polynomial is divided by a linear polynomial, then the remainder is the variable when replaced by the zero of the divisor. It gives a real number and that becomes the remainder. For example, if x cube plus x square plus x plus 6 is divided by x minus 2, then 2 is the zero of the divisor and p of 2 is the remainder, which is 20. We got it as 2 cube plus 2 square plus 2 plus 6. That is 8 plus 16 plus 2 plus 6. That is 20. Similarly, when we substitute the zero of the polynomial in the dividend and we get the remainder 0, then divisor is called the factor of the dividend. Should be very clear to everyone. Whenever the remainder is 0, divisor is the factor of the dividend. This is only the factor theorem. Let us see the definition. Factor theorem says that if px is a polynomial of degree greater than or equal to 1. Children, this greater than or equal to 1 is not here. You should write here. If px is a polynomial of degree greater than or equal to 1, that is, this px is dividend and a is a real number, then the divisor x minus a is the factor of the dividend px if p of a equal to 0. Similarly, we can say in the converse. Converse means we say in the reverse manner. Here we said x minus a is the factor, then p of a is 0. And in the reverse order, if say x minus a is the factor of the polynomial, then p of a is 0. Or in the other words, if p of a is 0, then x minus a is factor. Both are in the reverse manner. First time we said that when remainder is 0, divisor is the factor of dividend. If the divisor is the factor of dividend, then the remainder is 0. Suppose we take one example from the lower classes. If 10 is divided by 2, we perform the division, the quotient is 5 and the remainder is 0. So we say that 2 is the factor of 10. So this is about the factor theorem. It is nothing but remainder theorem, but the remainder should be 0. When the remainder is 0, the divisor is the factor of the dividend. Now let us see some examples. This theorem is very small, you have to understand, but lot of applications are there. So let us see exercise 2.4, in which the first question is, determine which of the following polynomial has x plus 1 as factor. Here there are 4 problems. I will be doing 2 and the remaining 2 you have to do by own. Here what is the question, children? Is x plus 1 a factor of the given polynomial or not? Factor means the remainder should be 0. So now we are going to check the remainder by replacing x by minus 1, as minus 1 is the 0 of x plus 1. Let us do the problems. So first one is, let us take the polynomial px as x cube minus x square minus x plus 1, and gx is equal to x plus 1 is the divisor, where the 0 of gx is minus 1 and p of minus 1 is minus 1 cube minus of minus 1 square minus of minus 1 plus 1. We know that minus 1 cube is minus 1. Minus 1 square is plus 1. Plus 1 into minus is minus. And then the third term, minus into minus, is plus 1. And the fourth term is also plus 1. So, plus and minus gets cancelled and the remainder is 0. So, what we have learned, children? When the remainder is 0, the divisor is the factor of dividend. So, what we say that because p of minus 1 is equal to 0, x plus 1 is the factor of x cube minus x square minus x plus 1. Let us see another example. Another example. You have to do remaining 3. We have shifted to second problem. The second problem is use factor theorem to determine whether gx is the factor of fx or not. Same problem, but the question is differing. Here also you have to find the 0 of the denominator or the 0 of the divisor and substitute that value in the dividend and see whether the remainder is 0 or not. If the remainder is 0, gx is the factor. So very simple. The 0 of the divisor is minus 1 and f of minus 1 is f5 into here 5x cube, so minus 1 whole cube, plus x square, so minus 1 whole square, minus 5x, so minus 5 into minus 1, minus 1. We know that minus 1 cube is minus 1, so minus 1 into 5 is minus 5. Minus 1 square is plus 1, so this is plus 1. Minus 5 into minus 1 is plus 5 minus 1. Again, plus 5 minus 5 gets cancelled. Plus 1 minus 1 gets cancelled and the remainder is 0. So, by the factor theorem, what do we conclude? That when the remainder is 0, divisor is the factor of the dividend. What is the divisor here? X plus 1 is the factor of 5x cube plus x square minus 5x minus 1. Rather, the correct point-to-point answer to the question is gx is the factor of fx. So this looks hard, children, but it is very easy. Go through the video once or twice or thrice also if you don't understand, and do the remaining problems of the exercise. Now similarly, in the second question I am doing one more problem. What is that problem? See whether again gx is the factor of fx or not. Here fx is 4x cube plus 20x square plus 33x plus 18 and gx is equal to 2x plus 3. So, what is the 0 of gx or the divisor? That is minus 3 by 2. Now find out the value of f of minus 3 by 2, or we are finding the remainder. 4 into minus 3 by 2 whole cube plus 20 into minus 3 by 2 whole square plus 33 into minus 3 by 2 plus 18. When there is minus and cube is there, the final answer will be minus. So, we have learned this in our lower class that a negative number with a even power is positive, odd power is negative. So, power 3 is negative, power 2 is positive, again power 1 is negative. So, power 3 is there, the final sign will be minus. 3 cube is 27 and 2 cube is 8. And when we cancel 4 and 8, this becomes minus 27 by 2. Is it clear? Now coming to the next term. Minus 3 by 2 whole square is 9 by 4. 20 into 9 by 4. 20 comes in 4 table. So we cancel 4 ones are 4 fives are. 5 into 9 is 45. Third term is plus into minus minus. 33 into 3 is 99 by 2 plus 18. Now let us simplify this. We brought both the fractions to one side and both the whole numbers to another side. So 45 plus 18 is 63 and minus 27 by 2 minus 99 by 2 is minus 27 minus 99 by 2. Children, here 8 is written there. Don't write 8. Write down 2. By mistake I have written 27 minus 99 by 2 plus 63 is equal to minus 126 by 2 plus 63. Minus 126 by 2 is minus 63. Minus 63 plus 63 is 0. So again we got the remainder 0. So factor theorem says that when the remainder is 0, divisor is the factor of dividend. Or 2x plus 3 is factor of 4x cube plus 20x square plus 33x plus 18. Or we can say gx is the factor of fx. Now let us see next question. Next question is, show that x plus 4, x minus 3 and x minus 7 are factors of x cube minus 6x square minus 19x plus 84. So here what we have to show, children? When the given polynomial is divided by x plus 4, the remainder should be 0. X minus 3, the remainder should be 0. And x minus 7, the remainder should be 0. Or simply we have to prove that p of minus 4 is 0 if the polynomial is assumed as px. P of minus 4 is 0, p of 3 is 0 and p of 7 is 0. Let us now find the let us assume the given polynomial as px is equal to x cube minus 6x square minus 19x plus 84. Suppose we are going to see whether x plus 4 is factor or not. To see that, we have to substitute the variable by 0 of x plus 4, that is p of minus 4. So it becomes minus 4 cube minus 6 of minus 4 square minus 19 of minus 4 plus 84. Minus 4 cube is minus 64. Minus 6 into 16 is 96. Minus 19 into minus 4 is plus 76 plus 84. This becomes minus 160 plus 160. So the remainder is 0. Thus p of minus 4 is 0. Remainder theorem converse says that if the remainder is 0, x plus 4 is the factor. So first work is over. Now let us see the second polynomial, whether it is factor or not. X minus 3 is factor of px or not. What is the 0 of x minus 3? It is plus 3. So now let us find out the remainder, that is p of 3. P of 3 is equal to 3 square minus 6 into, p of 3 is equal to 3 cube minus 6 into 3 square minus 19 into 3 plus 84, which after simplification is 0. Thus we see that the remainder when it is divided by x minus 3 is also 0. Therefore, x minus 3 is also the factor of px. And let us substitute the variable by 7, which is nothing but the 0 of the third polynomial that we are dividing to the given polynomial px. P of 7 is equal to 7 cube minus 6 of 7 square minus 19 into 7 plus 84. 7 cube is 343 and second term 49 into 6 is 294 and 19 into 7 is 133 and plus 84. So this gives you 0. Thus here also the remainder is 0. In all the three cases the remainders are 0. So all the three given linear polynomials are the factors of the given px, that is x cube minus 6x square minus 19x plus 84. Let us see another question, that is the 8th question, in which he has given if ax square plus bx plus c and bx square plus ax plus c have a common factor x plus 1, then show that c is equal to 0 and a is equal to b. Let us see what is given, try to understand. Both the polynomials have common factors. That means the remainder in both the cases is 0 when the variable is replaced by minus 1. So let us find p of minus 1 and equate it to 0. and let us find let us suppose first one polynomial to be p of x and second polynomial to be g of x. That is, px is equal to ax square plus bx plus c. Gx is equal to bx square plus ax plus c. X plus 1 is the factor. So, p of minus 1 and g of minus 1 both are 0. Or we can say that p of minus 1 equal to g of minus 1. Let us substitute minus 1 in both the polynomials 1 by 1. So, let us first substituting px, that is p of minus 1 is a minus b plus c. Because it is given x plus 1 is factor, so definitely p of 1 is 0. So a minus b plus c is 0. Now let us find out g of minus 1, which gives b minus a plus c is 0. 1 and 2 are equal according to the given data. So we equate a minus b plus c is equal to b minus a plus c. C gets cancelled. And then what is remaining? A minus b is equal to b minus a. From RHS will go to LHS, become plus a. B from LHS will go to RHS and become plus b. Thus we get here 2a is equal to 2b. 2 gets cancelled. Therefore a is equal to b. Now substitute a in place of b in equation 1 or 2, you will get the value of c. Equation 1 is a minus b plus c is 0. So instead of b, I am writing here a, that becomes a minus a plus c. Minus a plus a cancels, and thus we get c is equal to 0. Thus children, we have come to the final answer, that what is asked. What is asked here? You have to show that a is equal to b and c is equal to 0. So we have proved by factor theorem. It is a factor, so when the variables are replaced by minus 1 in both the polynomials, the remainder is 0. By equating both the remainders, we could get the final required answer. Let us see another question. Another question is, if y minus 3 is a factor of y cube minus 2y square minus 9y plus 18, then find the other two factors. We know that because here dividend is a third degree polynomial, it will have 3 factors or 3 zeros. One of the factors is given to you. You have to find another factor. What is the one of the factor? Y minus 3, and remaining 2 factors you have to find here. So what we will do is, we know that y minus 3 is a factor. When y minus 3 divides y cube minus 2y square minus 9y plus 18. Children, in textbook it is given minus 18, but I have written it should be plus 18. So let us divide y cube minus 2y square minus 9y plus 18 by y minus 3. So same division procedure. First, y cube divided by y will give you y square. Then multiply y square into y is y cube. Y square into minus 3y is minus 3y square. Y cube minus y cube cancels. Minus 3y square becomes plus 3y square. And plus 3y square minus 2y square will give you plus y square. Now bring down minus 9y. Again y square divided by y will give you y plus y. Now plus y will get multiplied to y minus 3, which will give y square minus 3y. Subtraction. Y square minus y square will get cancelled. And minus 9y plus 3y will give us minus 6y. And bring down 18. Then 6y minus 6y divided by y is minus 6. Minus 6 into y is minus 6y. Minus 3 into minus 6 is plus 18. And thus the remainder is 0. By the division algorithm, we know that dividend is equal to divisor into quotient. Already remainder is 0. Actually divisor into quotient plus remainder. As remainder is 0, we are not adding. So what is the dividend? Y cube minus 2y square minus 9y plus 18 is equal to divisor y minus 3 quotient y square plus y minus 6. So this quotient we can factorize by the process of factorizing quadratic polynomial. Now what are the factors of minus 6? So that we get the difference 1, that is 3 and 2 plus 3 and so like this we got the other two factors as y plus 3 and y minus 2. So the question is, one of the factors is given to you, other two factors you must find. Similarly, in 7th question also, you have to factorize. They did not give any factor, but you have to check with plus 1, minus 1, plus 2, minus 2. Wherever you get remainder 0, again like this process only, divide the given polynomial by that factor, you will get the quotient, factorize the quotient, you will get the remaining factors. 7th question also is same like this. 7th or 8th one, there he didn't give the factor and simply asked you to factorize. There you have to substitute for the variable 1, minus 1, 2, minus 2. Wherever you get 0, that becomes the factor, and do the division like this and find out the quotient and then factorize the quotient to get the answer. Try to understand it properly. Watch the video twice or thrice to improve your understanding. That's all about what I have done. I have given this exercise 2.4 as homework, and this is 7th sum only, what I said correct. And from this, from every question I have done, every model I did one problem. So seeking the help from my video, you have to complete this exercise and write in your classwork. First write the notes. Notes are very less here. Only you have to write factor theorem, and after that start doing 2.4. I have done many problems. Out from this only I have done the problems. Complete the exercise and be updated. Thank you all of you. Thank you for listening and trying to understand.